electricity is defined as the movement of charge. And so the movement is a really key point. So let's highlight that. So basically that the charges must be moving in order to have the phenomenon of electricity. Now, when we say charges, charge is a fundamental property of matter. So best example of a charged particle is a thing called an electron, which is found in every atom. So hopefully you kind of remember your kind of basic high school science, that inside of an atom you have a nucleus which has some protons which are positively charged, as well as some neutrons which are neutral, they don't have a charge. And then there's also a number of electrons which are in some sort of orbital in this atom. So it's not really orbiting in the sense of a moon orbiting a planet. It's a little bit more complicated than that, but the electrons form are really a part of this atomic structure. So these things are called electrons, and they carry a negative charge. Now the fact that we call this negative here, that the type of charge carried by an electron is negative, that's really a convention. So they carry a negative charge. The fact that this is negative, is a convention. So we have kind of chosen a coordinate system, if you like, for how we define charge, and it so happens we've chosen that electrons are negative. There's nothing in nature that says that it should be in some sense negative. It's just a label that we've applied. So electrons have this negative charge, and the protons have this positive charge according to the way that we've chosen to label them. Now the charge of an electron is the following. So it is negative 1.6 by 10 to the minus 19 coulombs. So that's a fairly small number, and the important thing for you to recognize here is the units of coulombs. So a unit of charge, the unit of charge is a coulomb. So when we count the amount of charge that something has, that's how we measure it. And another important thing to understand is that the charge of an electron, is indivisible. So there is nothing in nature that has a charge that is smaller than the charge of an electron. It is the kind of the fundamental amount of charge that you always find, and every charged object is always some integer multiple of this number. It's like a fundamental unit. So this is the charge of an electron. The charge of the proton is exactly the same but opposite in sign. Now, electricity is the movement of charge. If you have materials where electricity can easily flow, then that material is said to be a conductor. So a good example of a conductor is pretty much most metals are good conductors. So most metals are good conductors. And so we use them in our electric circuits. We often use, for example, copper or aluminium as conductors. And so the picture that you should have for a metal is that it would have some kind of crystal structure. So I'm drawing here like the atoms that make up the metal. So for instance, a length of copper wire, let's say that these things are atoms of, let's say, copper, for instance. Then they would be in some kind of regular crystal lattice. Of course, it's a 3D structure. I've only drawn a very simplified version here. And we have some electrons, and these electrons are able to move through the material. So electron are able to kind of move through this metal. So they're not really bound to the nucleus from where they started, not really bound to the atom. They kind of roam around. And that's what makes it a conductor. So not actually stuck to the atom, but able to actually move. So we have this ability for the electrons to actually travel, and that's what makes it a conductor. Now, a key point that some people find a little confusing in the beginning. So in this subject, we're going to talk about what's called conventional current. And conventional current is a sign convention. It's like, an assignment of a positive and a negative to something. And conventional current is defined as the motion of positive charges. Even though in many of our materials, the dominant conductor is negative. So the dominant conductor in a metal is an electron. Electrons are negative. Electrons are going in the opposite direction to conventional current. So this point is a little bit confusing sometimes. So first of all, this is a sign convention, which we have adopted. So there's nothing particularly physically insightful about this. It's just a sign convention. And basically what this means is if you draw an arrow and you say that there is a current, we use letter I usually for current, which is traveling in a certain direction, for example, in this case, left to right, then what this means is that we would have positive charges. If this was a system where positive charges were the majority conductor, positive charges move in the direction of the arrow. In the direction of the arrow. This would be for positive values of conventional current, so I greater than 0. So positive charges move in the direction of the arrow if our current is considered to be positive, which is the same thing as saying that negative charges move in the opposite direction. Moved in the opposite direction for positive values of I. So it actually doesn't matter from the perspective of analyzing your circuits. It doesn't matter whether the conductors are electrons or some positive species, but it's just important to recognize if you're thinking about the fundamental physics of what's going on inside of that metal wire, that the motion of the electrons is actually the opposite direction to the way that we draw the current. Again, it doesn't really matter, it's just a sign convention. And there are, of course, some systems where the dominant charge carriers are positive, so some semiconductors, for example, or charged ions in a battery, where you could have positive charges are actually the majority of the charge, and in that case they move in the same direction as the conventional current. But for metals with electrons, it happens to be the other way around. Again, it actually doesn't really matter, it's just a sign convention, but I wanted to point that out to you fairly early on so that you're familiar with it.